Thank you very much, Pari, for the friendly introduction. Yeah, hello everyone. Welcome a lot to our webinar today. My name is Jasper. I'm based in Hamburg, which is actually incredibly warm today. So yeah, I'm looking forward to this, and let's dive right in. So, what are we talking about today? Oh, by the way, I forgot. If you have any questions, feel free to QA during me speaking, and actually my two colleagues will potentially already pick up, or we can discuss in the end in the Q&A section. What are we going to talk about today? So we're talking about questions essentially. So it all starts with someone wanting to know something, and then originally the setup typically was for a lot of companies, there's some analyst that takes this question and answers it based on a database. So they are fetching data, performing some analysis, and returning a question. And what we're looking at today is like a kind of new method to do this, which involves, like, for a lot of these questions, to simply take the question and auto-generate the answer based on a database using an LLM. And then the analyst or the data scientist can optionally chime in, especially for more complex questions, but they don't need to worry about all of this, like kind of like standard requests, and can really just streamline and focus on the high value work. So what we talk about today and what's the goal for today is like essentially discussing the how, why, and for what of this new method of like answering questions based on databases. So that's what we're up for. Now, how do we get there? We need to rewind time by 1 month. And actually, it starts with one of our customers, which is YPulse. And YPulse, for those of you that don't know, it's a large media content provider. So they provide a lot of insights on, for example, like how brands perform, how youth perceive brands, how, generally all of this kind of marketing knowledge. And they have all kind of things. And we actually built a retrieval augmented generative chat for them. Now that was running obviously on their textual content, so like articles, news articles, essays, etc. But what they also have is what you can see here on the screen, which is like these dashboards. So you can see, I don't know if your screen is big enough, but you can see there are a lot of numbers about like how awareness, how purchase scores are, so very kind of like empirical data for marketing. And all of this data sits in databases essentially, and people would love to query against them. So they, for example, have questions like, hey, which food brands are popular among Gen Z? Or what are the top 5 brands in the media tech industry in North America? How aware are brands, etc. So really questions that ultimately require the system to understand the data that is stored in typically SQL databases in this case, and tables. And now, how do we solve this? And obviously, the naive approach would be to simply dump everything into an LLM in one way or another. Like, some clients even approach us and ask if they can simply fine-tune LLMs with their data. That's a very, let's say, ambitious approach. But also, like, if you're already familiar with RAG approaches, people just want to throw in the tables and build it off there. And obviously, there's some issues with this, and we can see them actually in this example I brought. I'll give you a second to read through this. For those of you who don't already know, this has been popular on Twitter a while ago. So it's like, yeah, questioning against ChatGPT about numerical numbers, essentially, 9.11 or 9.9, which is bigger. And it's like ChatGPT has this like notorious habit of like being really, really bad with numbers, and it's also been super confident on it. You can see it on the bottom, like even though it's using Python, it's seeing it's a different result, it still, sticks with its original answer. So the question is, why are these transformer-based models, so like ChatGPT, Llama, Mistral, Sonnet, etc., all these models of this world, why are they so notoriously bad with numerical and structured data? And how do we overcome this? And let's start with the why. So the whole reason starts with unstructured versus structured data, and that they require very different algorithms. And let's take a look to understand this in depth. So here we have a spreadsheet, which is on loans. So it's like essentially loans from a bank. And our aim is to predict like whether a loan defaults. So there's a lot of information. For example, what was the loan amount, how long the loan went, etc. And now we compare this to another example. This is actually an image in this case. So we have an image of a dog. Our aim might be to predict whether this is an image of a dog or a cat in a very simple way. And we can see the actual numbers underneath. Obviously, for those familiar with computer vision, it's like typically three matrices, the RGB format, and then every pixel, obviously one number for each matrix, so three numbers per pixel. Now looking at the left one again, and let's start with the spreadsheet here. When we look at every individual number, these numbers can be extremely informative on like the task that we want to perceive. So for example, imagine me, let's say I had a bet with like Pari, my colleague, like a sports bet, and now owe him $10. Do you think I pay him back? Well, of course I do. Like it's very easy. Like I'm a trustful colleague, so I will pay back the $10 to Pari. Now, let's say we made a crazy bet, like for whatever reason, and I owe $1 million to Pari. Will I be able, or will I pay them back? Well, I may want to, but obviously it's very, 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 very hard for me to do, despite me wanting to do that. And the whole point is that even though this is just a single number, like the amount that I owe to Pari, and this number is already very, very informative on the outcome, whether I'm going to pay it or not. So you can see how this information is extremely, extremely dense. And then the second bit that we need to understand on this more structured data is it's not only super dense, but also typically we can do manual feature engineering. So that means that, for example, if I haven't paid back like the $10 for like 6 months by now, I've probably forgotten about it. And without any like interference from Pari, I'm not gonna, start thinking about it and paying it back randomly. So we can combine, for example, the amount and the time that it wasn't paid to also get some further information. And that is what people would call like manual feature engineering. So in essence, we have a very, very dense, in terms of like information density, very dense data set. And we can manually kind of like see which things go together and help us make informed decisions. Now compare this to the right. How much does any individual pixel tell you about this image being about a dog? Well, probably nothing almost, right? Like you can't say select any pixel in this image to tell you that, this is a dog or not. Like there's basically no information whatsoever in any individual data point. And similarly, just by manually combining different pixels, you're also not going to find out anything about this image. So you have to rely on automatic feature engineering. And that's like overall the rough, how you say, like tension that we have between structured and unstructured data. So for the left one, when we talk about how do we address this, like we typically rely on a traditional or shallow machine learning. And then on the right, we can rely on these more modern methods of, for example, like transformers and convolutional neural nets. So what this teaches us that depending on data, we may want to use very different methods and algorithms. And we can see this here. This is obviously just an illustrative sketch. But for example, on the x-axis, we can see like kind of like what I call the unstructuredness. I know it's not the most scientific term, but roughly speaking, the more unstructured the data is, the more we go to the right. And also typically you can see this on the left, the more intense we need to get in terms of computation. So depending on what kind of data we have, we may want to use very, very different methods. And the top right method, the transformers and the LLMs are typically very well suited for sequential unstructured data, which would be text mostly. And then we have like some, for example, convolutional neural nets for like image data, and we may have very, very different methods for completely different tasks, Yeah, so that's the algorithm landscape. Now, how does this come back to like the actual task for us, like building a chatbot, right? Like building a chatbot where we can ask questions against some data. And this comes back to like what you might have heard of also like the LLM agents. So here we can see what this could look like. So we start on the top, like a user request comes in, like let's say, what is the number of orders in our stock at the moment, something like this. And then we have an LLM assistant that acts actually as an interface to other services. So the whole point is that these LLM can power an interface and they can leverage other subservices that may actually consist of different algorithms. So the next space is like the subservices, and those can actually be LLMs again, or like other language models. So for example, when you think about a classic retrieval augmented generative pipeline, you may have like the retrieval methods there. So you might have like some other language models, but you can also have very different things. So for example, just a SQL database, or it could also be like a tool set of analytical tools like that, provides the LLM with like regression analysis or with like a Python prompter where it can run these things, etc. So the important bit is like the LLM assistant in this case is acting as an interface. Now that's obviously an abstraction. How does it look in a more formalized way? So this is what the system in total looks like that we built for this client, that we want to build for this client or wanted to build. And obviously this is a little overwhelming. So let's focus maybe first on the left side. So typically when building these pipelines, we have an indexing bit. And I'm not going to walk you to get overly detailed here, but like roughly we start with some documents. We typically pre-process them. We index things. We create embeddings. We store them in a vector database. Additionally, we may store into a SQL database depending on what the task is, etc. And then at inference time, we have like the querying pipeline. So this is what happens when the actual users start using the system. Now, the other one was when we deploy the system. Now we have the querying thing. And here we can see again, like, a user may ask a question, it's running through the system, getting embedded. There's like a general task. There's like also a system reaching out to the SQL database, and that overall makes up the system. And then on top of that, for each of these different components, we actually have a ton of options to choose from. So there's very, very many different like models and components out there in this in the AI universe that we may want to leverage to actually build like really good systems. And that can look a little bit overwhelming. So let's fast forward it just by 1 month again to today and see what the systems in action look like. So the system we've built, and let me pull this up here, is currently running in a beta test. So I'm just going to show you the beta test that we run with these with our client YPulse, and we can see how these questions are being answered. So for example, how aware of the brand Apple are Hispanic males aged 16 to 30. And now let's see how this system eventually performs. Okay, and by the way, while I'm waiting for the answer, feel free to already add any questions in the QA system. So here we can see how it answers the question on the SQL database. So it comes up with an answer and like a overview of the data source. We can take a look. This is a beta test, so it's still like this is just for collecting feedback essentially. But we can see how it actually answers the question total weighted respondent count. It really gets into the details of what was happening. And we can also see the SQL query that was being used to generate this result. Maybe let's ask one other question just to get an idea. Something like this. So what are the top 5 brands in the media tech and entertainment industry in 2023, sorry, in North America? And again, the system is now actively generating a SQL query, reaching out to the database, and collecting the data again, and then again feeding this through an LLM and coming up with the answer. So we can see this works actually fairly well. We can see like the brands, we can see the scores that was based on. We can also kind of like go into the SQL query and inspect what it exactly did. So for example, how it defined the time span it was talking about, how it defined the region, if we want to really inspect if something's going wrong, etc., and see what was happening underneath the hood. So now let's maybe dive into the system a little deeper. So this is how it works. Unfortunately, I cannot show you their application, but I can show you the basically very similar application on dummy data. And now we can try to understand how the system is actually set up. So let's dive in here. And actually, sorry, let me start with the database. So this is the material we look at. So you can see it's a Snowflake database. We have a database in here with a bunch of like tables essentially. Let's just take a random look into something. So we have a lot of these tables. We can take a look at the data, just like probably some of the Some of you may also have in their companies, in your respective companies, similar data sets that you may want to query against. So this is what it looks like. And now we can have it build up a similar system. So we can ask questions here. Let me see. I think I've prepped something. So for example, how did sales develop year by year? Let's find out. And we can see how it comes up with like a table again. It aggregates the sales, comes up with some numbers. Again, we can see what the SQL query looks like. We can also want more maybe. No. See. I don't know. I think I had something like can't find my copied thing. What are the top territories? Territories, orders. Maybe something like this. And we can see it comes up with like this more extended table. Again, like running the SQL query, etc. Here we can now also see how the system is actually set up. So we can see there's also apparently some sources added to it. And this is like the retrieved sources. So let's try to understand how we got to this point and that the system actually works. So for that, we actually dive into the system itself and look under the hood of what is happening. So here we can see, let's take a look. We actually leverage two pipelines. So one pipeline is an indexing pipeline, you can see here, and one pipeline is the querying pipeline. Now, why do we have an indexing pipeline? Do we index the Snowflake database? Of course not. That would be probably not very reasonable step to do. What we do index is actually the column descriptions. So when we take a look in the files itself, we can see what the data is that we index. So in here, we can find descriptions of all the different tables that we have. And additionally, we added a lot of metadata. So for example, what are the columns that the system may want to use there or can use there, what the table is called, and then, potentially some other stuff in this file, just a file ID. So we create basically database with all of these table descriptions that we have that the system can leverage at inference time in order to understand like what kind of SQL query it needs to generate. So here we can really see all of the things available. And then when we run the system, and I'm clicking back, sorry, bear with me here into the system itself. What is happening at inference time is then that the system first retrieves the right tables that are informative for the respective query that we're facing. So there's like this typical retrieval process, as you might also have it in some more classic RAG setups. But then it's like based on these, it is generating a SQL query that is then executed against the Snowflake database. And the Snowflake database then obviously answers with like the extract from the databases, which is then again, of course, taken by an LLM, which formulates the whole thing into a fully fledged answer. And this is how the system is actually working under the hood, and which also, quite frankly, we've gotten quite good results from so far. It seems to be very robust. So yeah, this is the system architecture in essence. Now we can also look a little deeper, by the way, if you want to, how the system is exactly set up. So this is currently the YAML configuration. And for those of you who may already be familiar with Haystack, this hopefully looks pretty familiar. So this is like the Haystack description. This is like the prompts that we used, where we also did some testing to actually get to the results right now. So yeah, this is the total system. Actually, yeah. Let's go. So this was the demo on the two demos. So in essence, like, what do we do today? What are the main takeaways? So there's like four things. The first one is like these transformer-based models like ChatGPT, Llama, Mixtral, etc., unfortunately perform very poorly on structured data because of their of the nature of the transformer itself. Like the algorithm just isn't suited for this kind of data, and no matter what kind of like training you do, you will probably never get like to sufficient or very like satisfying performance with this. So what do we do to solve this? To solve this, you can build agents and use these models as an interface to other services. So this means that you use the ChatGPT because obviously you want to take a natural language input. Like, it might be simply that your CXO is asking a question on the database and it's just want to know, hey, how did our orders develop over the past 12 months or something like this? So you want them to be able to ask in a natural language, but unfortunately you need to, or fortunately, whatever, you need to attach other services underneath this, and this could be like this more agentic setup. By the way, this is the same as function calling, basically. It's just in terms of naming. It's also called function calling. And then these agents typically consist, and this is what I've shown you in our cloud, by the way. These agents consist of multiple interdependent components. So all of these different things that you've seen in the database, let's just quickly go back. So all of these things and all of the design or like data science decisions you make around there obviously influence the overall performance and they influence each other. So what you need to do is really orchestrate the whole thing. If you really want the system to perform well in the end, and that's what it ultimately comes down to, right? Like you want the system to be accurate, to be fast, and to be cheap, typically. So for these three things, you need to orchestrate all of these components in the most balanced and perfect way to really achieve peak performance. And by doing that, obviously, you can use Haystack, which is our open source tool, or you can also use our DeepSeek Cloud, our commercial offering, which is this platform that does this for you and where you can host all of this in one place. So yeah, actually, I was a little fast. Sorry for this, but I think there were a lot of questions, so I'm happy to jump into the discussion. And Pari, maybe help me here with moderating this. Yeah.
Yeah, absolutely. Thanks a lot. That was an awesome one, man. Yeah, we did have a lot of questions. Some of them in the chat and some of them in the Q&A section. So I'm gonna try my best to get to all of them. But let's start from the top. So firstly, like Ton asked a question: did you manually have to define the metadata? That is a very complex task and it's time consuming. So he has set up like hundreds and hundreds of tables with vastly different data. How would I automate the creation of the metadata?
Yeah, that's a very good question. Actually, we have this for a lot of projects that I think most of you may have been familiar that typically metadata plays a huge role in getting to high performance. And there's two ways to get metadata. So one is to just have it and add it to the system. So if customers already have to some degree descriptions readily available, that's obviously helpful. And the other bit is to create them. And typically for creation, it can be done via indexing, for example, during the indexing process, for example, via an LLM. It's also something I think we used in this case. Actually, Mo, maybe you want to add in a little bit here. But it's definitely those two options exist, and you can use an LLM for it. But if it doesn't, then you may wanna or you may have to go down the manual road a little bit. But typically with an LLM, you can get far ahead.
Awesome. There were like some questions that Mo and BJ actually already answered in the chat section as well. So maybe guys, Mo and BJ, could you guys come online as well? Maybe we can just get through all of the questions live. Hey, hi Mo. Thanks a lot. Thanks a lot for the help in the background. Hi BJ. So the next one was David, and I think Mo, you already answered this, but maybe you can touch on it. So David asked a couple of times, like, what does your prompting strategy look like?
Yeah, so for the demo that Jasper showed, the prompting strategy was based on having kind of two LLMs. The first one was responsible of generating SQL query. That's where kind of the prompting fine tuning comes in place, making sure to write clear instructions so the LLM knows what kind of information it should generate. This kind of goes through, multiple processes, trying different prompts here and there. Yeah. And then the second step, which is the second LLM, which is responsible of receiving the table from the previous step and then analyze it, provide insight. explain it, give it more context, so the final user doesn't have to read the SQL query or the table, but can just consume the insights, right? Think of it like that.
Awesome.
Yeah, maybe just to add to this, because I'd be also curious to hear maybe from you, all of you, what your experience is with the prompt engineering. But firstly, two main things on this. Like one is that typically it also depends a little bit on the model, so it's hard to get some overall guidelines because once you switch from maybe ChatGPT to Sonnet to Mixtral, you may find that different things work to a different extent. And the second thing that we typically find is that when you see like a project overall, like an end-to-end project, and you typically have three major buckets where you work on. So one is the prompt engineering, which is like kind of the generative part. And then the other two is like the retrieval part if you have some data. So this would be like in this case, also the retrieval mechanism. And the third bit is the data itself. And I don't know about you, but my experience is typically the vast majority of time is actually spent on these latter two, on like the retrieval and the data bit. Whereas the generation is usually like, if you got some good tooling around this, it's usually done in a couple days almost of like trying different things. And if it still doesn't work, you usually also have a problem at the retrieval or at the even worse at the data stage. Well, I'm pleasing.
Cool.
All right. Sorry, Patrick. Yeah.
No worries. So like we have an anonymous question here. So the question is like, why are you using Snowflake to build this solution as opposed to Databricks? Is it due to performance, cost, capabilities? In our
No,
case, it's client, right? Like, I don't know.
sorry, what you saying?
It's because the client was using Databricks, right?
Yeah, exactly. This is client driven. Like this would work equally well with Databricks, I assume. I know there's some different, like for example, probably for Databricks, you need to handle the Parquet format for data or some other things potentially. But yeah, this wasn't an intentional decision on our end. This was basically a customer requirement.
Okay. Then Satya Narayana has a question, so I hope it's like the full question that has come in. So he just says like whether the data extraction from SQL is real-time data at a particular time instance T. So I'm guessing the question is like, is it real time or is it just like on a set of like static data?
Yeah, so it's on real-time data that the client put in place for the project. Also, every time we query the table, the connection, we close the connection, and then we reopen it for the next query to make sure that we have the most updated data, right? So if you query a Snowflake database and you leave the connection open, and new rows come in, there is a chance that these new rows won't be taken into consideration within the open connection. So we have to open it and close it to make sure that we have access to the real-time rows, basically. So short answer to your question, yes, it's a live data.
Mm-hmm. Okay. And here's a question that had come in the chat. And I think maybe Vijay also answered it before, but maybe it's an open question now. So like, did you already evaluate the results with the validation set? And if so, how did they perform? Maybe a good way of looking at it is like, how do you evaluate this first, number one? And like, how has been our experience with it?
Oh, I let this to you. You're currently doing the evaluation. So
Yeah,
how do you do it?
so how we kind of assess the performance of this pipeline, mainly during development, right? When we started building this pipeline, we had access to a list of questions and answers that the client had provided to us, and that those answers is what the client expect from this Snowflake pipeline, right? So we had kind of a baseline to build on top, which was very handy, especially when working with a very specific industry like the one that Jasper showed. And that's how we kind of approach that, right? So we had this list, we fine-tune the prompts based on the results of the pipeline, compare that against the list. There is an experiment feature in DeepSet Cloud that help you provide ground truth. and it says that ground truth against your pipeline, and you have sort of a metric, F1 score, precision, recall, and from then you can decide if the F1 score is good enough to move this into production. And although this current version is beta mode, in terms of metrics, it's been doing good. The client is happy. They just need to try it manually, make sure all good, and then hopefully it goes into production soon.
Well, yeah, fingers crossed. Maybe also just a little remark on this, like in general, I would say for all of these applications, we always have a bit of a back and forth between like qualitative evaluation and quantitative evaluation. So qualitative, I mean that someone is literally sitting down and looking at the examples and going basically almost anecdotally from one example to the next, or even better, obviously the best is typically asking users, does this end application suit your needs? So that's one bit. And then unfortunately with this bit, it's like if you run too much from one example to the next, you get a little kind of like lost in the forest and or lost in the weeds. And then it becomes more important to go back to the more quantitative approaches like Mo just described. So this would be then like having a full-blown eval set and really doubling down on some numbers. Although I would always recommend don't get too crazy with like let's say F1 versus like MRR versus like some other metrics. Just focus on the main ones, and then once you're at a sufficient level, go back to the user and ask again.
And I think just to add to that, for like text to SQL in particular, we usually have some like ground truth SQL queries for like particular questions, right? Either directly passed on from the clients, or we kind of work with them to come up with one. And so then the comparison is like the final output of the SQL queries. So sometimes like the SQL query itself might be different, but the output can be the same. But then sometimes we also find that actually there's some nuances of the database that wasn't considered during the SQL creation. And then as we like go through the results, sometimes these ambiguities become clearer. So maybe the SQL query assumed some certain column was the right one for a particular question from a user. So let's say like what are the sales for XYZ, and then it's looking at certain categories within the database by column type or whatever. But maybe that might not be the case, like desired case later on. So yeah, just to say that during the evaluation, it also helps like clarify the use case itself as well. And I think on a little bit like switch back to the previous question. Also, one thing to add would be like this then also sometimes feeds back into the prompt itself as well, whereas we might add some use case specific or even database specific things into the prompt. So for instance, if the user asks for sales, give the sales by territory or whatever. It's like some good defaults, because we find that sometimes the user questions, the natural language questions, are quite ambiguous. So they could be in theory mapped onto like different multiple SQL queries. So it's not always clear that which like what would be the right answer. So in that sense, like sometimes the prompt we can also like include some default ways to go about it as well. Well, sometimes they can be like a good discussion point to like discuss the whole use case as well.
Got it. There's a couple of questions on like on how retrieving confidential data. So one of them is like, are we able to retrieve confidential? Are we retrieving confidential data? If yes, then how do we actually manage it and keep it secure? And the other one was like, as an LLM will be accessing my data directly from like a Snowflake account or something like that. So what is the risk that my data will be altered? So maybe you guys can take those together.
I can take the security question when it comes to data alteration. So the way we build this integration is we wanted to make as safe as possible, since an LLM has access to the data. There is a risk of someone, pull everything or change the data, right? So what we've done is we created sort of a barrier. So for every call to your Snowflake database, the integration check if the user has only read access. If the user has more than read access, write or delete, the integration will stop you from extracting the information. So you must have only read access to be able to use this integration. Hope that answered the question.
I'm sure it did. If it didn't, then just like ask again, and we can pick that up as well. You know. Okay, we're getting new questions. I'm just gonna go through this quickly. So Stefan is asking, can active learning be added to keep learning while running the RAG? I'm not sure I understand it, but
yeah. So this is actually, if I understood, the question is that learning in terms of having the right context, right? And maybe this answers your question, but tables are kind of gets updated a lot, not just the length of the table, but also the width. Right? You add more column to the table as you know, as you know, moves on time, right? So how the LLM knows that a new column has been added and incorporate that into the results is that's kind of the sometimes responsibility of the client or whoever is managing the database to update the pipeline with a new column, right? So the approach is here, especially for this use case, is a RAG approach, right? Where we took every column of the tables and we created a text file that define the purpose of this column, right? If you have a column that called age, we give it more context. Age of who responded, what's kind of the range of the age. These information help the LLM generate the correct SQL query. So when a new column comes in within the table, we're expected to add that into the pipeline, adding more information to that. So the LLM knows that the new column should be added into future generation. So that's kind of where we've seen active learning, quote unquote, within this project. But yeah, I don't know if BJ or anyone has something else to add to that.
Yeah, I think nothing particular, except like we also do have like a feedback mechanism where you can kind of flag the outputs, and yeah, it's not like it's being used like in the like what would be like an actual active learning setup, but it's more like we collect them and then later look at it and then see what can be done to improve on those particular questions. So yeah, it's more like, okay, collect the feedback and then we'll kind of look at them in batches later.
cool. Here's an interesting one though, by Naresh. Like, how do you handle some root cause or complex queries that cannot be handled by SQL? Will you prefer the other databases? That's all the question says.
So this would mean something like asking a query that
that cannot be handled by SQL, that's what I'm guessing.
So if a question is not related to the I mean, if the question is kind of out of the subject, that's what you mean, or
I'm not really sure. Maybe Naresh, you can clarify,
No.
Just ask another question. Yeah, Jasper.
Otherwise, maybe on this, so obviously, yes, there can easily be questions that go beyond like the capability of the system. And like right now, obviously these will simply fail essentially, like if you ask something wildly different, let's say. But like the idea, of course, being that going forward, you combine multiple of these sub-services. So let's say now we have this BI information from a SQL database, but then also like there might be other additional services like sub-services, like for example, the pure rec system on the articles, and then maybe additional even another system added to it. And then of course, the LLM assistant in the full agentic system, but this is like maybe a little down the road, would automatically decide on which tool to use and leverage the right one, and then also be able to handle different tasks. But to be fair, to getting this is obviously really experimental and exciting, but also like if you actually need to ship this, and in the case of Whiteboards, they have like, you know, a lot of paying customers who are using this, you may be a little bit more conservative, let's say, to be in contrast to being experimental around what works and what doesn't. I hope this helps. Yeah.
Awesome. Maybe we take like just a couple more questions, you know. So one of them is like for especially for the example that you were showing, which were the LLMs that actually work the best for SQL generation? Like, what did we test? Do you think there was like a clear winner out of all the things that we tested? Well, what do you think?
Yeah, so we tested two LLMs for this project, which are GPT-4o and the latest Sonnet 3.5. So we had them next to each other, and then we asked them the same question, and they compare the answers, right? Short answer, Sonnet 3.5 was way better than GPT-4o for this specific use case. I wouldn't say that Sonnet will be better than GPT-4o in every use case. I think it depends of the use case. But in this case, we tried these both LLM, and we found that Sonnet 3.5 was performing better.
Awesome. So we have another question now. Like, what about Mistral for SQL generation?
Oh, no, I haven't tried that one. Do you recommend it?
Okay, so we haven't tried it, so you have to tell us. Cool. I think most of it are now around like okay, so there's an interesting one by Satyanarayana again. Like, have we used like fine tuning, or are we using the concept of RAG over here? That is like, how is the system being informed? Like, you have to hit this particular table with the SQL.
Yeah, no, we have used. Oh, sorry. More.
No, go ahead. Yes. No, sorry.
Yeah, no, we have fully relied on RAG for this case. Also, it's something that I would say is, even in a broader sense, typically our go-to for most actual production cases in real life. This fine-tuning as, I would say, as a rule of thumb, if you can't solve it via prompt engineering, you will have a really hard time solving it with fine-tuning, because typically fine-tuning somewhat like just limits the space in which the model is answering or generating systems, basically similarly to what you would have also do when you prompt it. And so for that, like, I think the main benefit from fine-tuning would probably be that you can simply need less prompt, because the system automatically understands it will have to create a SQL query. But I would argue that you will not be able to bake in any knowledge, like, for example, what columns the underlying data system would have or something like this, that would actually benefit the LLM on another level. So that's why, yeah, my recommendation would be to refrain from fine-tuning unless there's clear reason to do so, because, for example, the model is extremely small and it's easy to do. And additionally, you also just want to have a specific tone or a specific vibe to the answer, in a sense, then it's a different story.
Got it. There's an interesting one they popped up of like advantage of using SQL here. So Jambier, if I'm pronouncing it right, is asking, is there a clear advantage of using SQL in this case, because it is directly acting on the database as opposed to Python, which sort of has to pull the data in?
Yeah, I guess part of the reason SQL might be a little better or better suited for this is that SQL obviously is easier to restrict. Like, you can, like with Python, you know, the system could go rogue in a sense, or it's very hard to limit it. Whereas SQL, like Mo said, you can, you know, basically relatively easily check if it's like read or write, and by that already have very limited like kind of like space of things that can happen. And typically what you want to do with these agents is like, you know, keep it as clearly defined as possible. And with Python, you may have like simply like a universe, which is really cool in the data science or exploratory phase to try different things, but it's not very helpful if you actually want to ship the application in the end. Mo, feel free to check me here, but this would be my explanation.
I'll probably argue that storing large amount of data, in this case we have millions and millions of observation in a database, and access that information through SQL is much faster and then probably cheaper than having to lean on Python to load all the information in your memory. Can impact your latency there. Also, want to add something else is that LLM tend to be bad in math. Everybody knows that. Using SQL to do some math operation tends to do better than asking an LLM to do 1 + 1, right? So that's something I want to add there.
Awesome. So I think this has become more like a training session now, because I have another question now. There's a question from Stefan. So he's asking, what do you recommend for fine-tuning the LLM with custom data sets and for building a training data set, like from a history of previously used queries?
Yeah, I mean, look, I'm freestyling here a little bit, but since this fine-tuning is such a big issue, I want to dive a little deeper maybe. And why? Because I feel like it's almost like a thing that pops up a lot and people overestimate a little bit of what is possible. So here you can see like what kind of options you have to adapt your system, like your LLM-based system to the kind of use case you have. And you can see fine-tuning in LLM scores really high on the change behavior as kind of like axis. So that would be something like it always answers like a pirate, or it always answers in a SQL query. But it doesn't really score very high on the change knowledge. And typically what you really struggle with at least in my view, in most commercial settings, is like actually changing the knowledge, right? You want the system to understand the company, the data, whatever. So that's that. Now, how does fine-tuning, do we still fine-tune? Well, yes, of course. There's different things that fine-tuning can mean, and then it depends a little bit on what you mean. So if you're looking at embedding and re-ranking models, then fine-tuning definitely plays a bigger role also in commercial settings, because it's fairly cheap actually to do this. It's also highly controllable. It's easy to come up with supervised fine-tuned data set. You still need a lot of data, but you basically only talk about minutes or hours, and you get better retrieval by it. In addition, a very similar thing, I don't have it here on the slide, but it's something like also training classifiers, etc. Now, when you come to the LLM bits, so like the Mixtral and Mistral and so on, from all the actual applications that we found, which are not like, I can see this very clearly being a thing for character AI, because for example, if you want to have the model answer like Albert Einstein, then fine-tuning might be a thing, because you could also get there via prompting, but it's kind of cumbersome and difficult in a conversational setup. So you may want the system to simply always answer like Albert Einstein, and that is something you can do with fine-tuning. But you will not get the knowledge of Einstein in it unless it already is there in a sense. Because what you would actually do probably in most cases will be just supervised fine-tuning plus some DPO or RLHF, which will require like some form of data, and it will be fairly manageable, but like a little bit. But what you're not doing is like what people typically imagine is probably like the self-supervised continued pre-training, which is just like essentially predicting the next word. And if you do that, like the times that I've done that, you really kind of like destroy some of the RLHF that happened before, or the DPO. So you have to go back to that again as well. And this already takes a lot of time and effort. And that's basically the only way to really change the understanding of knowledge. So yeah, I hope this helps. But this is my overall take on fine-tuning.
Cool. All right. I think I don't see any other major questions here. So I think we can safely close it because we're almost at time as well. So lastly, I just want to say, Jasper, Okay, so there's your details. So if anyone wants to get in touch with Jasper, that's all the information you need. But again, thank you so much, Jasper, for doing the presentation. Mo, BJ, thank you so much for the Q&A section and adding all the insights. Thank you, everyone who stayed till the end and asked all your questions. And yeah, we'll keep you informed about the next sessions that we do. Till
Yes,
then,
thank you so much for the attention.
thanks a lot. Thanks a lot for staying. Yeah, cool.
Thank you.
Thanks,
Bye-bye.
everybody.
Take
Thank you.
care, everyone. Bye-bye.